Hey everyone, I hope you guys are doing fantastic. Welcome to lesson 2 of our unit on polynomial expressions and equations. Okay, so lesson 1 was like super quick. It was just a quick kind of overview of, hey, these are the things you should remember from grade 10 and grade 11. Okay, now what we want to do is kind of dive into what do these things look like? And we're going to use some knowledge that we have from 10 and 11 as far as linear functions go and quadratic functions go, right? We've talked in grade 10 extensively about linear functions. And in grade 11, we talked extensively about quadratic functions, okay? So really, that part's not going to be super hard. We're going to add one more type of function here. We're going to add a degree 3 in 30-2. And we just kind of want to go through and see if we can look at certain items and figure out if we can get some patterns going. Okay, that's all. So quick review of some vocabulary. Just a reminder, a polynomial function is a function that has exponents that are whole numbers. In this investigation, we're going to use your graphing calculator. You will examine the effects of the degree and the sign of the leading coefficient. Now, just for clarification, let's just talk about that whole sign of leading coefficient thing. If I gave you something that looks like this, 3x squared minus 7x plus 2, okay? The leading coefficient, remember that we write polynomials in highest degree to lowest degree. We say it's descending order of degrees, okay? So the x squared was my first term because that's higher than an x to the 1, which is higher than an x to the 0, essentially, is that constant term, right? So the leading coefficient is the coefficient that's in front of the highest degree, okay? So in this example, the leading coefficient there would be positive 3, okay? All right, awesome. So this is going to involve a graphing calculator, so I want you to go grab one. I am going to review how to graph these on a graphing calculator just once, and then we'll just go with the pictures that I have on the PowerPoint. But as always, the best way for you to get the most out of these videos is for you to keep pausing, try and get the graph yourself, try and get pretty window settings yourself, and then put me back on and see what my picture is, okay? But I will go through the first one just straight from nothing so that we can talk about how to do things on a graphing calculator, okay? Okay, so in this first example, I'm just gonna hide my head here for just 1 second. We see that it is a degree 1. The polynomial is f of x equals 1/2 x minus 6. We see the number of x-intercepts is 1. Now, I actually don't see the x-intercept here, but I'm just getting ink on here. You can see that it would be over here, right? If I just extended that line up a bit. The y-intercept is at 0, -6. Remember that y-intercepts have to be in a coordinate point, so bracket x comma y bracket. And then the end behavior. So two things we're going to say here. Number one, we say whether it ends going up or going down. So it ends going up. And then we say it's from quadrant 3 to quadrant 1. So we can see it coming in on quadrant 3, and then it'll go out on quadrant 1. Just as a quick reminder, I've got 1, 2, quadrant 3, and quadrant 4. Okay. Now, don't say just because of the picture I showed you here that it ends on quadrant 4, right? Because it's going to keep going up. Even if you don't see, that pattern is still going to keep going, okay? Now, let's just take a minute and we are going to graph that together. So the equation is 1/2 x minus 6. So just as a quick review of graphing calculators, I'm just going to switch what I'm sharing here with you. We're going to switch over to share my calculator. Now, this is a Casio. If you have a TI, I will walk you through similar items with a TI, okay? But on a Casio, you're going to press menu, and then you're going to go to option 5. So you can just press 5 for graph, okay? And now you're looking at Y1, Y2, Y3. My TI friends, you will have a button up here that says Y equals, so you'll just press that button, and you'll get to the same thing on your screen. Now, we're going to go -1/2, so that's -1 fraction over 2. So my fraction button is there. If you have an older calculator and you don't have that fraction button, the other way you can do that is just go bracket -1 divide by 2 and close your bracket that way. Those guys mean the same thing, okay? If you're a TI, alpha y equals 1 will get you a fraction button if you have a new operating system. Or you could go alpha, and I think there's a button over here on the newer models that have a shortcut to that fraction button as well. Okay. Okay, I'm just going to delete that. 1/2 x. So x is your variable button. On a Casio, it's right underneath your alpha. On a TI, it's right to the right of your alpha. Okay. So, oh, you know what, friends? I didn't have -1/2 there. Now that I'm thinking about the example I just gave you, it was +1/2. So I'm just going to delete that negative sign and then -6. Okay. And then you hit enter to save that equation. And then TIs, you can do the same thing. And then you're going to hit draw. So on a Casio, that's F6. On a TI, it's the exact same button. You'll have a button right here that says graph. Okay, and we see this at the moment. I'm not in a standard window. So a standard window goes from -10 to 10 on both the X and the Y axes. You'll notice right now, my Y axis only goes from -3 to 3. So I'm just gonna go Shift F3 to get to my window. TI friends, you can do the same thing. There's a button on, it is like your third button in, and it says window, okay? And I'm just going to change this to a standard window. So for Casio kids, you'll see right now F3 is your option there. Just a reminder, Casio kids, everything you see down here corresponds to the F1, F2, F3 buttons, okay? So we're going to go standard. On a on a TI, you're going to go zoom standard, which I think off the top of my head, I don't, oh, here's a TI. Just a sec now. I think it's zoom 0, but I will tell you in one quick second. Zoom, uh, no, zoom 6. Sorry, my bad. Zoom 6 is your standard window. Okay. Okay, great. So then I just exit and I redraw. And now I can see a closer picture to what I was showing you on the PowerPoint. Okay. All right, I'm going to switch back to the PowerPoint. Okay, and we see the same picture there. Okay. Awesome. Now, the purpose of this investigation, as we go through the rows here, I'm not going to give you as many things. Again, you're going to pause me. You're going to try and fill out all these things, and then you're going to look at my answers. Okay, that's how we're going to play this game. It's going to be so fun. Okay, so the next one, I have a degree 2. I did tell you that. And the polynomial function is f of x equals 2x squared plus 2x plus 4. I am going to, yeah, pause me. You fill it in. Sorry, I was hesitating because I thought, oh, maybe I'll go back and graph that one for you, but I'm not gonna. I'm gonna show you the picture. And then I do want to graph a cubic with you. So I will show you one more graph on the graphing calculator, but right now, pause me. You try and fill this in and then come back. Okay, all right. Welcome back. This is what you should have. Okay, again, I kept my window standard just so you kind of see where I am in relation to a standard window. The number of x-intercepts for this guy is none. It never actually crosses the x-axis. The y-intercept is at 0, 4. And then the end behavior, we're ending up, and I'm going from quadrant 2 to quadrant 1. So remember, we read graphs left to right. So coming in from the left, I'm coming down on from quadrant 2, and then I'm going to turn direction and come out this way, and I'll be ending in quadrant 1. The number of turning points is 1. The number of turning points is exactly what it sounds like. It's the amount of times you change direction. You turn. That's why it's called a turning point. Okay, so couple of things I want to start bringing to your attention. In that first example, just let me get my ink on here if I can find it. In that first example, we had 1/2 x minus 6, and it looks something like that, okay? And so that's a bad drawing, but all I want you to notice here is my leading coefficient was positive, and I ended up. Here, my leading coefficient is positive, and I end up, okay? The other thing I want you to notice I'm just going to switch colors here to have this conversation. My constant term. My constant term was -6. And if you go back and look at your work that you just did, the y-intercept was 0, -6. Take a look at this guy, friends. My constant term is 4. And take a look at, oh, I can just go right there or right there. I'm just having fun drawing on the PowerPoint, it seems. My y-intercept is at 0, 4. Okay, so the other thing I want you to start connecting here is your constant term is going to show you your y-intercept. And the sign of the leading coefficient is going to tell you whether you end going up or down. Okay. Okay. Yay. Try this guy. Now, this guy I would like to do with you, graph with you. So I'm going to switch my screens one more time. I'm going to head over. So it's -x cubed. Maybe just write that down before I switch screens on you. -x cubed minus 2x squared minus x minus 2. Okay. So if I go back to my graphing calculator, okay. And I'm gonna go, I just press exit to get back into my y equals. TI kids, you can just press the y equals button again. I'm gonna go up and I'm just gonna type right over what I have there. So this is -x cubed. Your calculator, both Casios and TIs, will understand the difference between a negative sign and a subtraction sign. You need to start with the negative symbol, not a subtraction symbol. Otherwise, you'll get a syntax error, okay? So -x cubed. Yeah. I wanted to do this one with you because notice when I pressed the exponent button, which was up here, you got that cute little box here. If you're a newer calculator, you will get that cute little box. You just have to remember to right click out of that box so that you're back down. Do you see how my cursor just went big now instead of small? If I go back, see how my cursor is small because it's an exponent right now. And then if I press the right button, my cursor gets big because now I'm back on a regular line, okay? If you had left it small, everything you type is going to be in the exponent, and that's not actually what you want right now, okay? So -x cubed minus 2x squared and minus x and minus 2, okay? And then I hit enter to save that. If you, same with the TI, if you are typing something like this, let's say I change this to 5, and let's say, oh, I didn't want to do that. Nothing actually on a Casio is registered there until you hit execute. So notice this, let's say, oh, I didn't want that. All I have to do is press exit, and it goes back to the last thing it actually saved in there. Okay, so then I'm going to draw. And I've got this cute little guy. Now, I actually, we might as well, while we're here, have a conversation around window settings. What I want you to notice here is there's a bunch of wasted space, right? If I look at this, I can say, hey, sorry, just getting my ink on here. None of this is really helpful to me. It's all just white space. None of this is really helpful to me either. So I could adjust my windows so it kind of goes from there to there. And that might like let me see this curve a little nicer. Okay, so maybe if I wanted to do that, first I want to get rid of all those scribbles I made. Okay, let's go to my window. So I'm going to go Shift Window Settings. TIs, you just press your window button. And let's change that to, I actually wasn't looking at the graph. Let's say -4 to 5. Let's just see what that does. See if that gives us a better picture. Okay. So I press exit and I redraw. Okay, much better picture. But now I can also see, now that I remember the numbers a bit, I like the -4, but maybe I only want to go to 3 here. Because again, this is still some wasted space, right? So I'm going to go and change this to 3 and then just redraw. And that gives me a nice picture, okay? All right, so let's go back to the PowerPoint. You're going to want to keep filling stuff in. Okay, so figure out the number of x-intercepts, the y-intercept, the end behavior. Hey, maybe you can answer the y-intercept now without the picture of your graphing calculator. Hopefully you're going to say it's at bracket 0, -2, right? Because it's going to be the constant term. hopefully, based on the previous conversation we had, you're going to tell me the end behavior that it ends going down. And if you remember from the picture, that was going to be what? Quadrant 2 down to quadrant 4. And the number of turning points will actually be 2. So this is all the stuff that we just talked about. Just verify you got all your answers there. Okay, awesome. Let's try this one now. Again, I'm not gonna graph it with you now. So you pause me, go ahead and try and get a nice pretty window and then come on back, okay? So for this guy, we have a degree 3 again. In that first degree 3, the leading coefficient was negative and I ended up going down. In the second guy, the leading coefficient is, in the second cubic, sorry, the leading coefficient is positive, and so now I should be ending going up. I'm going to end up with one x-intercept on this guy. My y-intercept is at 0, comma, -2, and I can see that here, and I can see it at the constant term. It ends up, so I'm going from quadrant 3 up into quadrant 1. And again, the number of turning points is 2. I have a turning point right here, and I have a turning point right here. Hey, I don't know if you caught this yet, but when I had a degree 1, that was a straight line, and there was 0 turning points. When I had a degree 2, that was a quadratic, and I had 1 turning point. And now I'm looking at these degree 3s, which is called a cubic, and I have 2 turning points. So what I want you to notice is that I always have 1 less the number of turning points than what the degree of the polynomial is. So if I had a 10th degree polynomial, which by the way, we won't do to you in 30-2, but if I had a 10th turning or a 10th degree, so x to the 10 was in my equation, I'd have 9 turning points. Okay, there's always 1 less the number of turning points than the degree of the polynomial. Okay, let's try this guy again. I'm going to get you to pause me. Okay, so hopefully you have all of this done, and this is what you should be looking at. We are a degree 3. This time there are 2 x-intercepts. And I've got a y-intercept at 40. No, friends, that's a mistake. Take a look at this. I don't know where the 40 came from, actually. Sorry about that. That should say 36 for 2 reasons. Number 1, I can read it right off the graph here. Number 2, there's a 36 sitting right there. So we're going to adjust that. That's just Peter not reading through his notes after he finishes the PowerPoint and before he does the video. Sorry about that. So that should be 0, 36. Okay. Okay, end behavior is ending up because I have a positive leading coefficient, and I'm going from quadrant 3 to quadrant 1. And again, the number of turning points will be 2 here. Okay. All right, let's try this guy. I'll get rid of that ink on you. So pause me, fill it in, and come on back. All right, so this is the stuff you should have here. Degree 3. This time the number of x-intercepts is 3. I've got 1 here, 1 here, and 1 here. The y-intercept is at bracket 0, comma, -10. I end down. And I'm also going from quadrant 2 to quadrant 4. And again, the number of turning points will be 2. Okay, so let's just walk through a few generalizations here. The maximum number of x-intercepts. Well, for degree 1, I want you to notice there was always 1. It went straight through. For degree 2, I could have, let me just draw this out for you and see if this will help you. So degree 1, I always had 1. Okay. A degree 2, I could have none. I could have 1. I could have 2. But I could never have more than 2. Okay. A degree 3, I could have 1. I could have, I'm just going to extend this. I could have 2, assuming I actually hit there. Okay. Or I could have 3. but I can't get more than 3 because I'd have to change direction again, and then it wouldn't be a degree 3. So the maximum amount of x-intercepts that I can have is actually going to be the degree of the polynomial. Okay. The y-intercept comes from the constant term. And then the end behavior is known from the sign of the leading coefficient. Okay. The last thing we talked about there was that the turning points, there will always be one less. So turning points is one less than the degree of the polynomial. Okay. All right, that was awesome. So let's now kind of flip it, and I'm going to give you a picture and ask you to come up with some of these things. So using your findings from the previous table, complete the following. Well, when I look at that picture right away, I know that that's a quadratic, and so I'm going to say it's a degree 2. I can see that moving over to the right side here, I'm ending going down. Okay, when we say end, we're always talking about kind of over to the right because we read graphs left to right. Okay, so I end down. The sign of the leading coefficient should be negative. The constant term, well, the constant term is actually going to be right around here, right? It's going to be where I hit the y intercept or the y-axis, okay? And so it looks like it's not going to hit -5 there. So it looks like it's about halfway. So we're going to say the constant term is going to be -4.5. End behavior, we actually just talked about. I'm going to end going down. But when we talk about the end behavior, we also want to talk about, hey, I'm going from quadrant what to quadrant what when I'm reading left to right. So I'm going to be from quadrant 3 to quadrant 4. Okay, quadrant 3 to quadrant 4. The domain is going to be, x is a member of the reals here, because this is going to go to the left forever and to the right forever. So all the values of x such that x is a member of the reals. Make sure you're writing domain and range with proper notation. Okay. And then the range will be all the values of y that are less than 0. So all the values of y such that y is less than or equal to 0 and y is a member of the reals. Okay, less than or equal to 0 and a member of the reals. Awesome. Okay, so next up, let's try this guy. Now, I know this one is the kind of newer one to you, but hopefully you're going to look at this. Maybe you forget some of the terminology, but right away I can say, hey, I've got 2 turning points here, so that must mean I'm a degree 3. And as far as terminology goes, just remember, we call a degree 3 a cubic, okay? C-U-B-I-C. Okay, so it is a degree 3. Sign of the leading coefficient, I'm ending going up. And because I'm ending going up, that'll be a positive. The constant term, again, it's a little less than -1. If I have really good eyesight, which I don't because I have old man eyes, but it looks like it's at -1.2. Okay, -1.2. The end behavior, I end going up and I'm going from quadrant 1, 2, 3, right? So quadrant 3 up to quadrant 1. My domain will be real, and my range for this guy actually will be real as well because I'm going down forever and I'm going up forever. Okay? We got this, guys. We're doing awesome. All right. You want to try another one? Of course you do. Okay, so this guy, again, I've got 2 turning points. Okay, so I know I'm going to be a degree 3. Sign of the leading coefficient is going to be negative because I'm ending down. Constant term, I need to find my y-intercept. It looks like it's going to be at 6. End behavior, I am ending down, and I'm going to go from quadrant 2 to quadrant 4. So I'm coming in on quadrant 2, and I'm going out on quadrant 4, okay? Domain will be real, and range will be real. Okay, again, I'm going to go left and right forever, and I'm going to go up and down forever. Okay? Awesome. All right, friends. Next thing to chat about is zeros versus x-intercepts versus factors, and just kind of making sure we understand the difference between those, okay? Zeros x-intercepts, I'm looking for where I hit the x-axis. Where does my graph, where does my function hit on the x-axis? There's a relationship between zeros and x-intercepts. They are the same thing. They're just written differently. So zeros, we say x equals something. X-intercepts, we'd say bracket x comma 0 bracket. Okay. So the zeros of this guy would be x equals -1 and x equals 2. The x-intercepts would be at -1 comma 0. Don't forget the brackets around it. It's not a coordinate point if you don't have brackets around it, okay? And 2 comma 0, sorry. 2 comma 0. That is a typo. Everybody yell at me. That's a typo. Okay, 2 comma 0. Please accept my humblest apologies. And then the factors, well, think about this. In 20-2, we solved quadratics using factors, right? So let's say, this is just an aside, but let's say I get to 0 equals x plus 5 and x minus 7. You would have said, oh, okay, x equals -5 and x equals 7, because you took each of those factors and you set them equal to 0, right? Okay, so what I'm doing with the factors then is I'm saying, what would I have set equal to 0 to arrive at this conclusion, right? X equals -1, that would have had to have been x plus 1 equals 0, okay? So if I had x equals -1 and I want it to be 0, I have to add 1 to both sides. So that's x plus 1 equals 0. So that would be my factor, okay? Likewise, if I had x equals 1 and I wanted that to equal 0, I'd have to subtract 1 from both sides. And so that would be x minus 1 equals 0. Okay. And so that would be my factor. So my factors would be x plus 1 and x minus 1. Okay. I'm going to get rid of the ink there. Just a reminder that this is not right. I'm still going to scratch that out, even though I got rid of the other ink, because I want to make sure you realize that that's a 2. Oh, nobody yelled at me that I did it up here as well. Oh, I guess I did it everywhere. My bad. Okay, so let's get the factors on here. I apologize, guys. Let me get the factors up. Okay, and so I'm going to just make my corrections for you, okay? So this guy should have been -1 and 2. And then 2 comma 0. I don't know why I noticed it on the x-intercept, but I didn't notice it on the 0. And then my factors here would be x plus 1, and this would have been x minus 2, okay? You forgive me? I'm sorry. I'm sorry. Okay. I'm going to assume you forgive me, or you shut the video off, and now there's no chance. So if you're with me, you forgave me. Okay. Let's try this one. Okay, so I'm hitting at 1 and 4. So my zeros are x equals 1 and x equals 4. My x-intercepts then will be bracket 1 comma 0 and bracket 4 comma 0. And then my factors, remember, I need to think, okay, if x equals 1, what would that have been as a factor? That would have been x minus 1 equals 0. So x minus 1 is a factor, and x minus 4 would be a factor. Okay, x minus 1 and x minus 4. Okay, awesome. Let's try this one. So now I've got 3 of them. I'm going to hit at -1, at 0, and at 3. So I've got 3 different zeros, x equals -1, x equals 0, and x equals 3. I have 3 x-intercepts. It's the same number, except I have to write them as a coordinate pair now. So I'll have bracket -1 comma 0 bracket. Don't forget the brackets, okay? For x equals 0, that's actually the point 0 comma 0. And then 3 comma 0 for the x equals 3. Okay? And then my factors, well, this one will be x plus 1. This one is actually just x all by itself, okay? Because x already does equal 0. I don't have to add or subtract anything. And then this one will be x minus 3. Okay? Yay. Okay. Try sketching. Y equals x minus m, x plus n, and x plus p. Okay, so really, what we need to see here is my x-intercepts would be at m, at negative n, and at negative p. Okay, so really all we're trying to do here is think, okay, if I just drew, if I have a x-intercept at, I just want to switch colors here. So at a positive, so I'm just going to put this guy as m, and let's say this guy is negative n, and this guy is negative p. Okay, it's just kind of arbitrary. But now I just connect those dots, and it would look something like that. Okay, that's all. Okay, so I gave you like a computer generated one where I put numbers in. But take a look at this picture for a sec. Okay, everybody got that picture in your mind before I erase it? Okay, gone. And now look at the drawing that I did on a Casio graphing calculator. It's the same shape, right? I've got two x-intercepts. I mean, now they're -5, -2, but that doesn't matter, right? I had two x-intercepts on the left, and I had one x-intercept on the right, and I connected the dots, okay? All right, we can do this. Totally okay. Let's summarize what we have talked about today, okay? So in summary, okay, I'm just going to hide my head in case I'm over the words there. The maximum number of x-intercepts a graph may have is equal to the degree of the function, okay? The degree of the function. The maximum number of turning points a graph may have is equal to one less than the degree of the function, okay? I'll hide myself again. The blank of the equation of a polynomial function indicates the end behavior of the graph. That is, do you remember? The sign of the leading coefficient. Okay, the sign of the leading coefficient. If that leading coefficient is positive, the graph will end up. And if the leading coefficient is negative, the graph will end down. And then the blank term in the equation of a polynomial function is the y-intercept. That is the constant term. Just remember, the constant term will be a number. The y-intercept will be a coordinate point, right? So the y-intercept will be bracket y value, or 0 comma y value bracket, okay? Okay, for odd degrees, the y values will head in opposite directions, okay? So what I mean by that, I'm just going to put my head back here. What I mean by that is the following. This would be an odd degree, okay? And so if I look this way, I'm going down. And if I look this way, I'm going up, okay? As opposed to an even degree, okay? On this side, I'm going up, and on this side, I'm going up, okay? So opposite directions for odd, and then for even, it's the same direction, okay? And then the factors and the x-intercepts and the zeros are all related to each other, and that was the slide we kind of did right before our summary. X-intercepts say x equals some number. Sorry, zeros say x equals some number. Well, now you're losing faith in me, so let me write it down. So this say, if I had, let's just pick 3, just as an example here for us, okay? So the 0 would say x equals 3. The x-intercept would be 3 comma 0. And then the factor would be x minus 3, like that, okay? And if you want to get even more math, like algebraic, we could just call it a letter, okay? So the zeros, we could say x equals a, and then the x-intercept would be a comma 0, and then the factor would be x minus a, like that, okay? Okay, are you all still with me? You feeling okay? Not stressing anybody out, I hope. Okay, we can do this. We got this. All right, so let me clear that, and then that is it for this video. Now, you have a fair amount of stuff to practice, which is awesome, right? The more you can practice, the better you're gonna feel about it. So take a look at that and connect with me if you do have any questions. And hey, thanks for watching this video with me. I love journeying with you as you go through your math stuff. So thanks for letting me come along for the ride. Thank you for letting your friends know about these videos too. I really appreciate you guys getting the word out about these videos. That means a lot to me. And of course, thank you for subscribing to my YouTube channel. That also means a lot. You guys are awesome. You can do this. I believe in you. Go have fun. Go do your homework. Take care, guys.